Okay, so hello everyone, first of all. Yeah, so I put this session about looking a closer look at the Databricks. In the last, let's say, more than a month, been working with data team, and we are deploying. We deploy Databricks from ground up, and we're going to go through a little bit of like the model they're using. What is Databricks? What is Data Lakehouse? Because that's the model. And we're going to have a look at architecture in AWS, and we're going to have some demos at the end where we can see Databricks in action, and we can actually see how it's actually working. So let's see if I can check the slides. Okay, cool. So for the summary of the presentation, first, I think in order to understand Data Lakehouse, we have to look at the evolution to Data Lakehouse. So how it's all started from data warehouse, the data lake, and the data lakehouse, and what's the difference between them. There's a lot of terminology. So we also have to cover the Delta architecture, something that Databricks calls the Medallion Architecture, and also a Delta Lake, because this is proprietary to Databricks. And then hopefully in the second part, we'll have a look. We have two demos. I prepared two demos. The first demo, we're going to dive into the data lake and into the Delta Lake, actually. And we're going to run loads of commands. So we're going to start from scratch. We're going to create a database. We're going to read a Parquet file. We're going to convert it into a Delta file, into Delta tables. And then we're going to perform certain operations so we can see the advantages of using Databricks. And in the second demo, we're going to run a model where we have streaming. We have loads of streaming inserts being pushed into a bronze table, and then we will configure an automatic pipeline that detects the changes in the bronze layer and starts modifying the data. So we will see that this is a Databricks concept, the bronze, silver, and there's also a gold layer. So we'll discuss about this in the next few slides. Okay, so if we're starting with the evolution of the Data Lakehouse, and I'm not going to spend too much time on this, but basically the evolution of disk storage opened the door to IT processing by introduction direct data access, and on top of that, combined with the high performance and direct data access, the online transactions became possible. But with the growth of applications, new problems appear. Is we have a lot of data, we're now finding the right data, and also we're finding the same data in many places with different values. So this required a solution. So data warehouse appeared. I think data warehouse initially it started in the 80s, and it just led to disparate application data being copied into a separate physical location. And this way, the data warehouse became an architectural solution to an architectural problem. And obviously came with a complete new infrastructure. So we store all the data on a completely different infrastructure, like in this case, a data warehouse. And the data warehouse was nothing more than just the storage at the end of the day. So it had little value without the analytical infrastructure, which comes with like metadata, where we can find where the data is location, the guide to what data is located where. We have the data module, which is an abstraction of the data in the data warehouse. We have the data lineage. What kind of transformation has that data been through to get to this point? We have, apologies, that is summarization. The data lineage is what type of transformation has data been through. And the KPIs, the key performance indicators, and also the ETL, which obviously is the technology that allows application data to be transformed into more corporate data. But the data warehouse also hit the limitations. And it just mainly began with the increasing variety of data. Data warehouse, until now, the data was pretty structured, so in like table forms. But we're getting more and more, we're getting different types of data, like textual and other unstructured data. So structured data could usually is, it's mainly a transaction. So it's stored like records, could be a payment or a call, something like this. We have textual data, which could be like emails or text conversation inside a company between two members. And but I think the biggest problem here with unstructured data, because the unstructured data came in forms of IoT data, video, images. So with unstructured data, we can think like, for example, like video, we could have face recognition. Images, we can have, I don't know, social media interactions or like images, for example, X-rays. So we have loads of data, but I think the biggest chance comes from IoT data, because there's like, you can have loads of sensors that record thousands of transactions and send it to your data warehouse. Also, the rise of AI and ML, the algorithms require direct access to data, not based on SQL. So in this case, we can name, for example, TensorFlow. I think TensorFlow is using like Python, so you cannot query that. You cannot use SQL queries to get access to data. Okay, so this led to the emergence of the data lake. So the data lake is like a combination of all different kinds of data found in the organization. It supports multiple types of data, structured, I think also like semi-structured, textual, and IoT data. It's using open source file formats like Parquet, and the type of storage is usually low cost. So if we look at AWS, a data lakehouse could be in S3, which is very low cost storage compared to data warehouse. In AWS, you have to provision Redshift, which is quite expensive. But the data lakehouse also has its challenges. So usually we have huge volumes of data that we have to process. And also there's a concept of data swamp. So with the huge amounts of data, if we don't insert data with precise metadata, then making data retrieval could be very difficult. So you can end up having loads and loads and loads and loads of data that is not being queried and just sitting there for ages. And yeah, this is like called swamp, called data swamp. Okay, so the next concept is the data lakehouse. So the data lakehouse, it combines the flexibility, cost efficiency, the scale of data lakes with the data management and ACID transactions of data warehouses. And it provides open APIs with lots of different languages. So you can query, you can run SQL, Python, R, and other languages. So in a nutshell, data warehouse and data lake is pretty much the data lakehouse. Okay, so in this slide, it's pretty much an image that shows the evolution to data lakehouse. And like I said, in the 80s, data warehouse appeared, and it was pretty much an ETL that sends the data, inserts the data in data marts and being consumed. The data lake offered a bigger variety of data to be ingested, and then the data lakehouse even more. So it's a more, let's say, mature and unified model. Okay, so now that we covered the data warehouse, the data lake, now we can look at the Delta Lake. So the Delta Lake, now we're moving into Databricks territory. So Databricks Delta Lake is an open source project that enables building a lake house on top of existing storage systems. So I assume companies that were already using Data Lake move to the Lakehouse model. So they already have they have a lot of data in S3 if using AWS. ADLS is the data lake storage from Azure. GCS Google, and HDFS is Hadoop. And yeah, it's a combination of APIs combined with open file formats. Like we mentioned earlier, it supports different kind of languages like SQL and Python combined. And basically it transforms unstructured portion of the data lake from being managed at the file level to a logical table level. As I mentioned, Delta Lake is something Databricks came up with, but there are others, like Uber has Hoodie, and Netflix has Iceberg. Okay, and the way Delta Lake works, it stores, so it transforms the data and it stores the data Parquet in a file, in a DBFS, which is Databricks file system. So, and it maintains a transaction log that accurately tracks changes to the table. So it's pretty much like ACID transactions. And yeah, it makes data ready for analytics. That's pretty obvious. Okay, so now let's look at the Delta Lake model in the diagram, because the diagram is like 1,000 words. So we have different scenarios here. We can see that the Delta Lake has the concept of 3 types of tables, which is called the bronze, the silver, and the gold. And we're going to look in more detail in the next slide about how we can use this table to clean data, to make data better. And the way it works, obviously, we have streaming, and also we can have loads of batch that will just put the data straight into the ingesting tables. So the bronze table is the raw table. So it's raw data without any filtering, without anything. So raw data. But obviously, we can the Delta Lake can sit on top of our data lake. So let's say we already have a lot of data in S3 in our data lake. And yeah, so this concept from Databricks, it's also referred as Medallion Architecture because of the colors. And the data is organized into layers or folders as defined as bronze, silver, and gold. The bronze is raw data. Like I said, it's ingested from various sources like relational database or JSON or IoT, and it can come from a Kafka. A Kafka can stream all this data and append it in a table, and it keeps appending the data. Then there's no cleaning, no transformation, so it's just raw. Then Databricks can apply some transformation, and the silver, and it will update the silver tables, which are more refined. We can do, for example, we can join fields from various bronze tables to improve streaming records or to update account statuses based on recent activity. We can do other things like loads of cleaning. We can apply a schema. We can do filtering, and this is usually the table where data scientists plug in, because the data is already cleaned a little bit. They don't have to do the unfun part of going through the bronze layer and just scattering through the data. So yeah, data scientists love this. And the gold layer is more like a business level aggregates, which is used for dashboarding and recording. So the way I think of this layer is a board meeting layer. So this I'm saying this because from one of my previous jobs, we had to get this data for board meetings. So it's pretty much someone clicks on a nice dashboard, prints a page where they have aggregations like weekly sales per store or the daily active website users or gross revenue, stuff that you need for decision making in a company. Okay, so before I move to the next slide, I thought about this concept when I first saw this concept, and I thought that this is we build this in IT world, but it has such a good significance to something that we do as humans for probably hundreds and thousands of years, and it's incredibly similar. So if you look at the model, it's very similar to the water treatment process, and also the name Data Lake. It's incredibly close to what we're dealing here. So it's pretty much the same. We have water in a lake which is unpurified. I mean, it's pure, but it has sediments and everything. That's the raw layer. That's the bronze layer, and then we start water treatment. So we're going to screen the water. We're going to remove the particles, remove the bacteria. So this is the silver layer, and then we have the water ready for consumption. So the gold layer. So I find it quite interesting how similar these two different processes are.
That's a nice analogy. I like that a lot.
Yeah, it's actually this is my favorite slide. I must be honest. This is my favorite slide because when I thought about it, I said this is incredible. And yeah. Okay, so Databricks set up in AWS. So now we're going to go a little bit on the more. This is a very DevOpsy slide. I don't know if I can make this a little bit. Oops. I want to make this a little bit better so everyone can. Oops, no, maybe not. So can everyone see maybe just slightly better? There we go. So in order to use Databricks in your AWS account, the way you set this up is Databricks has this split into a control plane. So the control plane from Databricks side is on their AWS account, and then you have a data plane which sits in, say, our Databricks account. The way to make this work is you have to set up an IAM role where you give permissions for the control plane to jump in your AWS account, and you give it permissions to spin up Spark clusters, basically. And then, yeah, Databricks has two concepts. There's the concept of an admin account. So the admin account would be the control plane. So this is where you log in. This is where you can create a new dashboard. And then you can instruct and say, I want a cluster, and I want each Spark cluster to have this many nodes. I want to use spot instances. And when you define that, then you create the workspace. The workspace gets created in the control plane, but the instances will start spinning in your own account. So this is in a nutshell how you set it up. So you have to work on the security-wise, of course, to make sure that the IAM permissions are pretty much limited. That's it. And I think I'm going to cover quickly this because I think someone asked last time whenever we did the presentation about Databricks pricing, how it works. So they have three types of subscription. So you have a standard, a gold, and an enterprise. And the way they charge you is depending on what kind of compute you run on each cluster. They charge you based on what they call a DBU, a Databricks unit. And I mean, obviously, this doesn't include the cost of instances that you run in your own account. So premium and enterprise. In this case, we have premium, and let's say we're running 10 instances, 8 hours a day, 20 days a month for an i3 large is 640. So this is how you calculate the pricing. Okay, so the next slide is a bit, again, it's more real life architecture and how the Databricks Lakehouse fits into an AWS environment. And this is somehow similar to what we're trying to build in Kidsloop. We have two different. We can have a lake house in S3. So, for example, the data in S3 is being pushed by for example, like a database migration service that connects to Postgres and MySQL, and it pushes the data here. Or we have data coming from streams, like a Kinesis stream that ends up in the same table, and the Databricks Lakehouse sits on top of the, it supports S3, so we can query the data directly from S3. And to make it easier, you can also set it up to have access to AWS Glue. So it has a catalog. It has access to your catalog, so they know where to find the data. And yeah, this is pretty much like how you would set up in your organization. Cool. So that was pretty much it. And now what's the time? Okay, still good. I'm gonna have a go at 2 demos. So what we're gonna do in this demo, we're gonna create a DB, get a Parquet file, and then we're gonna create lots of tables with Spark and SQL. So we can show how, like we said, we can use Spark, we can use SQL, we can use Python. We can convert Parquet to Delta, we can visualize data. We'll have 2 write streams and 2 read streams to see real time. We're gonna check the ACID transactions. We're gonna do some schema enforcement, and then we're gonna do what they call time travel. So basically we can restore, because we have ACID transactions, obviously we can restore data back in time. And then we can do rollbacks and some other stuff. And the demo too will get back after it. Okay, so this is one of the Databricks workspaces. So this Databricks, I'm not going to go through this. We have a data tab here, and you can see the compute is here. So this is how I define my cluster. My cluster runs Spark. I have some options here, and I say I want to, the worker type needs to be M for large, and the driver type needs to be M for large, and I have min workers, max workers, so it's nothing. And then you have notebooks. So you run these notebooks, which is pretty much like a document that has loads of commands. So for this demo, first one is diving into the data lake. Okay, so I'm loading the notebook. Okay, first of all, let me drop the database because I've already tried this. Hopefully it will work. Okay, so as you can see here in this notebook, this is a notebook that's provided by Data Lake, and it has lots of commands in the presentation, so it's really nice to have a go and run. And what are we going to do? First time, before we start, we need to create a database. So we're using Spark commands here. So let's try and create a database called. First of all, let me check on data. Okay, so I have no databases, right? So I'm going to run this. Okay, cool. So now I should have a Delta DB table. Delta DB database, not tables yet. We haven't gotten there yet. Okay, so in order to use some data for demo purposes, there is a Parquet file which contains some lending loans, which is public from the internet. So I'm going to run this. What it does is just downloads this to the DBFS, remember, the Databricks file system, which is actually an S3 bucket that is configured automatically when you create the workspace. Okay, so now we can get started with the Delta Lake. So we have a Parquet file. So now what we want to do is we want to transform the Parquet in Delta tables. So we want to start creating Delta tables. So what we're doing is we're setting the path. This is the path where the Parquet file is, and then read this file and save as in format Delta, and save the tables as loans Delta. So I'm gonna run this. Okay, so this is running now. It's finished. So now we should have a table here in the data. So, okay, maybe, yeah, there we go. We have loans, right? So this is in Spark format. Alternatively, we can also create a delta table using SQL commands. So we're going to create a loans table too, by using SQL commands. See how it works. Okay, nice. So now we should have two tables here. Delta table, yeah, loans two tables. Okay, so we can do different things. But we can convert a Parquet to Delta in place. So can do this, and it will automatically convert into into Delta. And then we have different tools for visualization. So we can use Spark commands to see the data. So okay, so I mean, we loaded this Parquet file. So obviously this is as batch data. So we have a batch of 14,705 records. And remember this number because we're gonna start a stream, add to it, and then we're gonna roll back, and hopefully we'll get back to the same number. So yeah, this is the first batch. Now what we're gonna do is we're gonna start two streams, two write streams and two read streams. So this is just using a function that's generating like dummy data and creating these streams. So we can see how it actually works in real time. It might be a little bit slow because I've not used very big AWS instances, so it might not be as fast. But hopefully we can see some real time writing of the data. At the same time, what I'm going to do, I'm going to start two reading streams. Sorry, I think I'm pressing some buttons. Okay, I'm going to start two reading streams. Okay, so we can see that it's basically writing like 500 records a second. And then we should, this is reading, and also we should display some visualization. The first read is by type. So we should see stream 1 and stream 2. And this one should be by time step, so 10 seconds. So we should see a big bar for every 10 seconds of inputs. So hopefully they will appear in time because I don't want to run this streams forever. Okay, so while we're doing this streaming, nobody stopped us to doing a batch query. So while everything is running, we can run a batch query in the meanwhile. Yeah, like I said, it's a little bit slow. Didn't want to abuse the AWS XX large. All right, oh, there we go. So as you can see, we have the initial batch of 4,000 plus records. And now we have two streams, 12,000, 12,000. And this is by type. And this one should show for each second, 10 seconds. Okay, so I'm gonna stop hammering this. And see, maybe it will show us the graph. There we go. Yes. Okay, so we can see the stream A and stream B. So yeah, this is the way to visualize. Let me stop all streams. No. Let me stop because also my laptop is on fire. Okay, so we looked at streaming. Let's see what's next. ACID transactions. With data tables, you can see history of all the transactions. So we can see here we have loads of streaming updates. Now the next bit is that we can use the schema enforcement to protect the quality. I think for this exercise we can try to insert a new column called credit score. So let's try and do that. So I think here we just define the new column and then we're trying to append it, but this should fail. Yes, so this should fail because the schemas won't match. So Databricks something called schema evolution. So all right, so now we can actually see that the credit score column has been added to the Delta table. What else? Another feature is Delta-like time travel. So if we describe the history first, let's have a look what we have here. So yeah, we have all the streaming updates. We also have the write, which we did earlier, to add the credit score column. And then we can use time travel to go back. So this command as of run the first version of the data set. So we go back in time to where we had the batch, the record. So if I run this, we should get the 14,705 records, which we had at the beginning before we started the streaming. But in total, if we're running the, we actually have over 100,000 in this table. So yeah, this is a nice way to go back. So I don't know if you go back to like 5, we'll get probably a different. So this is like midway through the streaming. Oh no, still shows version 5.
Is that like just a version number that?
Yeah. So yeah, exactly. So it's exactly like in S3 you have versioning of files and you have different versioning. So you can actually query data query a table from a certain point in time without restoring. You just read the data at that point. So you can say version as 0, and then it pretty much goes at the beginning of.
So is that like controlled by? Let me put my video on. Sorry, it's a bit antisocial, isn't it? So is that kind of?
But like, I can't see anyone. So
yeah, I know. Yeah,
maybe I should. Okay, now
still here. I'm sure of it. We're all talking about you on a Slack channel. So is that kind of up to me as the programmer to go, actually, the version, I want to like baseline my data at this point, and I issue a command.
Yes.
Yeah. So I could do that like every hour or like at midnight.
Yeah, of course. The way I see this is almost like a git tag. So you want to go back in time to a particular moment in your and you will see that not only you can read, you can actually restore the data. So it's you can apply data, you can do some operation, then you realize, oh, I actually did a mistake, I want to roll back in time. But remember, this is ACID transaction, so everything that you do, it will show up. So you can roll back in time, but it will show up that someone. And I think there's also I think there's an example later on where we can actually tamper with some data, but obviously we can see it because of the transactions.
And so and you can roll back an individual roll, or you have to roll back.
Yes, we can actually roll back. Yeah, yes. And I think you will see that right now we have the count is 100,015, but we will roll back to version 0. So we will pretty much get rid of all the streams. We will delete all the streaming data that we insert.
Cool.
So this is actually what I was talking is roll back. So we can do restore the table as of version 0. So if I run this, it will just restore back in time. And
does that lock that table then while it's doing that, or like how?
Like if someone else is running on the same table at the same time. Not really sure. I think it would make sense to have some sort of lock, because otherwise, I'm thinking if 2 people run 2 different notebooks at the same time on the same, it makes perfect sense to have some sort of lock.
It's a cool feature though. I love it. But
yeah, and it's actually, I mean, if you would have like a proper cluster, like you set up in a company with like big instances, this will take like no time. Just I'm running super small. Okay, so we roll back, and now let's do a select count again. There we go. We're back at the same number of records we had before we started streaming operations. Yeah, so we have it has support for lots of delete, updates, merge into operations. So I think there are a few examples here. I know that I'm limited with time. I'm trying to get to demo number 2 as well. It's quite an interesting one. So yeah, we can delete data. I'm not going to run this. We can also insert into. So we can run insert to. So let's see what this does. Okay, so insert in one. Okay, cool. And we can also run updates. So the refunded amount is 22,000. We changed to 23,000 for this loan ID, and this should so just updates. So now we should see 23,000. Yeah, and it also has a feature for upserts. So you can have different way to specifying if the record exists, then update. If the record doesn't exist, then insert. So you can do that. And also has some special features, which is one is called a vacuum and deletes all files no longer needed by current version of the table. So it's really good. Like it's almost like yeah, it's almost like cleaning the cache, but it actually cleans the files. We also have this allows to cache the results of frequently used in memory to speed up the queries in advance. So they have this, and they also have something called Z-optimize, which I have to read. It's a multi-dimensional data clustering technique to collocate data for the fastest queries possible. That's pretty much the first demo. Okay, so the second demo, which is the CDC. So the CDC is basically, let me see if yes, I have this. Yes. So the CDC, we're going to try and propagate data from bronze to silver in an automated way. So we're going to have a job that reads the data as it comes to the bronze layer, transforms the data, and we'll see what kind of transformation we're doing, something simple. I'm going to move it to a data lake silver table. Obviously, I didn't have time to set up Kafka. So we're going to use, we're going to use a function that generates some random streams. So first of all, I need to make sure I delete this. Okay, then we're going to generate some fake data. So we have data with inserting a name and location. So we have Seinfeld and Derivary, and we're going to insert 100,000 and 100,000. Right, so we're going to have this. It's basically like a stream. Boom. Okay, there we go. And then we're going to write all this into a bronze table, into the bronze layer, and format is delta. So it's a delta table. We're going to run this. Okay, that's done. So let me see if I can see the data. Actually, we don't have a database in this case. So now what we're going to do is this function defines a stream. So what it does, it reads from the bronze, and then it will try and split the names into the last and the first. So what we're going to do is you see the names here. It's called Seinfeld, Jerry. So we're going to split these two names. So we're just applying some transformation to this data. I'm going to write it, and then we're going to write it to the silver layer, right? So we're going to run this. We already pushed some data. So it should start reading, and give it some time. I want to see the tape. I want to see the processing happen here. There we go. Okay, so it started processing here, and now it dropped because it stopped. There's nothing coming, right? The stream actually stopped pushing anything to the. So if we query the data now from the server, we can see that data has been transformed. So we have two new table columns with the last and first name, and let's go count. So this is a nice way. So obviously we push 10,000 and 10,000. 1 million, 1 million. I think skip this. No, it's not, but it's 50-50 anyway. So, okay, why is it not 100? Is it 1 million I pushed? Probably I pushed 1 million or 1 million. So, but anyway, it's half. So we have Seinfeld and David. So now what we're going to do is we're going to import more. So we're going to add George into the mix. So we're going to run this. Our streaming is, our job is still listening. So what we should do is we should see a spike coming here, right? There's new data will come in. This is still running. As you can see, it's still running. There we go. We see the spike of new data coming in. So now, if you run this again, hopefully we will see George in the mix. There we go. We have George. Okay, and that's pretty much it. We can see I don't know what these two are. Yeah, so this is the data in bronze. So we can see that the name is with a comma, and then the data that was seen transformed in our silver layer is being filtered by last name. And that's it. That's pretty much Databricks.